Oh, 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 oh. Oh. Holy moly. All right. So I have zero clue what we're gonna do. It's I don't know. This is fucked. We'll try to figure something out, but that's really all we can do. We can give it a go. Hope for the best. Basically, I have more or less figured the concept out, but I have not figured the implementation out. There are a couple of things. I think I want to have a class in my voxels for storing a vector. If not multiple. I'm not sure. I don't know what to call it. This is like vertex container. But that's the thing. It shouldn't really be a vector 3 position either. It should be more like an int position. I could use 3 bytes. because the position data is supposed to be I think I'm gonna go with 3 bytes. I was gonna go with 4, but I don't know. I think 16 levels of volume is probably too much, honestly. 8 is a better value. Perhaps. It depends. Because what you can do is if you have a volume of a certain size and you're using like pixel art textures, then you can match the two, right? And that's the benefit there. But I think I don't really necessarily want to do that, because I think I'm gonna use maybe like 32 or something like that. 64 times 64 resolutions for textures. I'm not sure, but it's gonna be more than 8 and probably more than 16. 16 is not very big, but I'm not 100% sure. But I don't want it to be tied to the texture if the texture is at a higher resolution than something like that. Also makes modding harder. I think. I did have a bunch of epiphanies this morning, but I still don't know about really how to do this. Because I don't know if this should also contain a neighbor, right? Because that's one of the difficulties here. Like, sure, this has a vertex, but what vertex is it connected to? We can't know that ahead of time. So it's a little bit that's one of the things there that I'm like not really sure about what the hell I'm supposed to be doing with. But yeah. Plus, I think one vertex can actually be connected to multiple. Like up to 4 or something. Well, yeah, it can. That's obvious. Which means, like, should I have 4 connections here that we manage, like some kind of, I don't know if that's what a surface net is, but I feel like it's close. The reason I want this is because I do not want to store vector 3s inside of the voxel. So now we're gonna have a voxel, a vertex container. That's null. Oh. As such, I don't want each vertex to contain, or each voxel to contain an actual data set there, because that's gonna suck. So we just have some implementations that we're gonna have to try and like struggle through. Because I don't think I can actually program this on my own just like that. Like just I don't think it's realistic. So what we need to do is we need to find the vertices. The plan is to find the surface vertices, set those, and then that's where I'm not sure, right? Because if I don't connect the vertex to another vertex, then I can't know which one it's connected to after the fact. That information is just lost. It could go anywhere. And that's why I feel like they have to be connected. And when I send them to the GPU, I think I need to store it as a voxel, and that voxel contains 4 vertices. And then we just do triangle checks against them, and that's it. And we don't need to do any neighbor shit. What that means though is that each vertex needs to contain a color and a position, which is all good because the position takes up like 9 bits, I think. But it does kind of suck, I think, a bit. Well, I guess each vertex doesn't need to do that because we have the voxel itself. The voxel will contain the color. And then we can do neighbor checks. If I want to transition between them smoothly. So, how do we generate these vertices? That's what I'm a little bit iffy about. I have this here. This is Python implementation. Dual contour, vert array, vert indices. For x in range, find best vertex. Like he does this first here. This is where I'm a little bit. I don't know if this is what I should be doing. Find best vertex. We're like passing in Fs and normals and shit. Changes, append. For each sign change, location VI, we find the normal NI. But I think I was kind of in the right mindset yesterday, even though I'm still like completely foggy. We basically have to I have to generate the information that we want here. So what is the corner here? Is no, it's not a vector. It's a float. The edge is 12. We have 12 edges, I think. Oh. That's where we then have to calculate each side. No, we don't want the... What? I don't know if we want the edge. We want corner and we want side. This would be 6. And so... side 0 equals voxel matrix xyz dot volume plus voxel matrix xyz dot volume, but this is then -1 on z. And then this is 0, -1, -1, +1, +1, +1. That should be it. There. If this was on the GPU, I would give a shit, but since it's here, let's just do division. I don't know. I don't know if division or multiplication is better for stuff like this. Okay. I guess it's still better to do that. That's that, right? And then the corner, which I'm a little bit iffy about, is gonna be something like this then. Maybe this is just fine here, I'm not sure. Nah, let's do this. Plus I want it to be like this. This is now going to be a little bit more annoying. Because now here we have to decide corners, and I think I should just go with what I have been using so far. And that means that corner 0 is... bottom left. That means x minus 1, minus 1, minus 1. But I want to go in... this actually needs to be even more. And this, I think this is going to suck ass. Basically. But... so... yes, this is true there. And then... this is then x. I don't see how I could do it in any other way. It has to be like this. And then these are just a repeat. Actually, no. Let's do this. Like that. And then this one here. There, 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 there. And then this is just a repeat, except y is like that. This is basically how it is. Like, I don't know how to really do this in any other way than maybe creating another matrix, which we could do. The corner matrix. I think that would actually be irrelevant. It would be the size of The matrix -1. Should I do that instead? I feel like that makes a whole lot more sense than this shit. Like that. And that is going to contain a corner. It's just the voxels shifted up to the right. And then it's just the volume in between. That's what this is gonna be. It could contain, we could double it up. Maybe. No. I think it doesn't, I think it only makes sense for the corners. Not for sides. Because we can shift it in a way where it makes sense and fits. But we can't do that with the sides. It would have to be 2. It doesn't make any sense. And then here, we have generated our thing. I really wish you didn't. I wish I could just type with my mind or something. Having to take your hand off your mouse is the worst thing in the world. And this is where we have to do what I was doing down here. but this might be the wrong one. So yeah, I think this should check up to the right. It should start in the bottom left and check up to the right. And it should basically be like 1, 2, 3, 1, 1, 3, 4, 7, 7. If this is the entire matrix, then we should check here first, and then we should set this to the average of these. Check this, set this here to the average of these, and then we stop here. That's why we start here, and then we continue up until we get to here, and then we don't check here, and then we check here. We set this, and we've set that, and then we check that. That way we get a net of corner volumes, and we won't have to calculate that every single time we do something. And the edges, they aren't real anyway. Every edge voxel is not really included in the surface. Like, not really. I mean, it can be. It can be. It's just that we have to treat everything outside as 0. It's that simple. Everything outside is 0. Then it works. This corner is 0. Or should it have +1? Like, should I set this corner here? The real question is, maybe it should be an integer. Maybe it should be rounded to an int, and the corner volume should also be an integer. I think that should probably be the case. Okay, let's say this is +1 instead. And then here I want to do something like and then in here we need to do something like let's do this. If this doesn't work, it's a little trickier than this. We have to do it like per. It has to be like this. If b0 equals, if x equals 0 or y equals 0 or z equals 0, then 0. Else, if... No, that's the only scenario, right? Else, we're gonna set it to... V0 is always XYZ. Yeah. And this is how it has to be. Like that. And then V1 is vulnerable to x equals world size in voxels.x. And then this is some bullshit. This one is just x plus 1. And then this one, this is where things are gonna become a little bit ugly here if I'm gonna line these all up, which I kind of want to do. But this is gonna be if z equals world size in voxels I think both of them are vulnerable to that. And 0, 1, 2, 3. 3 is also vulnerable there. And here then, these are all Y. And now we just need to line this up. Like that. And then this is just a repeat of that. And so is this. However, with this being done like this, we can just do this. Where's the Boolean? Right. This needs to be wrapped like that and like that. Then we can get rid of that and these. And now we should be creating a matrix there. I'll be right back. All right. Damn. But if we're in the bottom left as the default position, that means we go there and then we go +1 there and +1 there. Then this is just the same. +1 in the Y. And then we have a corner matrix, which I don't know if it's actually going to be useful. But I think so, because the corner calculation sucks. Like, checking your neighbor is fine. Checking a corner is not fine. Because a neighbor is just 1 + 1 divided by 2. This is 8 different neighbors. Therefore, I think this is worthwhile to own. But that doesn't really bring us much closer. Because the issue is still what to do here. Here we now have moved that up. This should be irrelevant. And this should now be a vertex generation. And here we now have to do the same thing here. This needs to say if like x equals 0 what exactly do we need to check here? Yeah, if x equals 0, but here it's if z equals 0, here it's if y equals 0, here it's if x equals 0. And here it's if x equals world size in voxels dot x, I think. Y and dot z. Then we're going to say then 0 then 0 else this. But I feel like it's not correct. Like it's kind of. Actually, it might be. It might be. Yeah. It is. It is. It's fine. It's just like if you take these two, add them together, and then divide them, that means that this side still has a value, even though it's 0 here. But the point here is to get the like that's the point, right? Because that was an issue I had before in certain cases where I was trying to smooth it, and that meant that like adding together a 0 with a value and dividing by 2 would give me like a value when instead it should just be 0. But here the point is that if the value on this side is less than the central volume value, then it's outside. That's how it's used. More or less. And with this, I now have the side volumes and the corner volumes. Right? And now we need to make some checks here on the sides and compare those. And this is where, unfortunately, concept ends, and we now need like actual implementation. And that's where I don't really know where to go. That's where we need some backup. Find best vertex. This is where I'm like a little confused, kind of. I feel like this is like This deck comes after almost, but apparently not. Here we're returning a mesh. And that's why I'm thinking, like, maybe... maybe this should be, like... if this is just an int... what? Huh? Am I having a stroke? There we go. And then here we can do some bullshit. Or we just return it as an int. How did you clear it? It was like a wiggly. I don't know. I feel like this is bullshit. It scares me. Let's just do the one I know. We do that. We do that. Then we flip those. And then we set. Something like that. Like that, I think. Do something like that. Then the question is, how do we handle the corners? Because there's technically 5 vertices in each voxel, isn't there? In a sense. Because each voxel gets assigned 1 vertex. But if I then want to store the actual quote-unquote quad, that's an additional 4 vertices aligned to the edges. But it's actually 4 triangles. Like, I think it has to be 4 triangles. And the reason for that because if you have a space that looks like this, and you have the central vertex is like there, and then let's say you intersect here, here, here. Right? Because in this scenario, we'd end up with this. So here it's 3 triangles. But if it was to be a plane, or let's say it intersects like this, then even if this is based on this, like you could now just do this, right? And you just make 2 tries out of it. But I feel like it could just as easily be like this is like slightly elevated, and then you'd end up with this instead. Or maybe it wouldn't ever end up like that. But I mean, it does in the previous scenario. I feel like it did. Because that's part of one of the scenarios in the examples, right? That it's finding the best vertex for a corner. And in that scenario, it does end up like that. That this vertex is part of the... is like the vertex. And that's the thing, right? Like, you're supposed to tie this together with the vertex in here and over here and over here. And then this is supposed to generate the surface, right? Like, that's really how it's supposed to work. But because I'm doing it's voxel based with ray marching, I feel like I have to store the the internal vertices. And in that case, that means that we're gonna end up with actually with a lot of vertices. Potentially. Man, how is this gonna work? Because this isn't necessarily, like, this vertex doesn't necessarily just contain one surface. Because this is gonna be like this too. Right? So I'm gonna have to store... That's a shitload of data, bro. All of this will have to be stored inside of the voxel. That's... Not necessarily all of it. Because it's a surface, so we should at most need to store like this. That's still 1, 2, 3, 4, 5, 6, 7. Really? 1, 2, 3, 4, 5, 6, 7. We have 7 vertices in one voxel. Wow. That's fucked. But even so, a lone voxel would still be 8 vertices. So we do need to store 8 vertices per voxel, I think. Because it's not so easy, like, you can't just store a dynamic amount of data on the GPU. It's gonna have to be an indexer, or like a count. Which is even more data. So it's just a byte. If even that. It can be baked in as just a few bits. But it would be... It would mean that... each voxel would be... like 75 bits? Which is still doable, but that's 75, and then we need voxel info like transparency and images, or like texture, or type, not texture. An index, rather. Fuck. That's kind of ass. But it's not a big deal because we're still only storing the surface voxels. Because I think I've kind of figured out how to do that in memory as well. You need to index everything, or you index every voxel in GPU memory, and then when you find that voxel, if the value is like 0, then we know it's empty. But otherwise, if it is like 1+, then it's an index pointing to a position in memory. I think. I don't know if that makes sense either, to be honest. But I think that's how it has to be, but that also makes me wonder, like, okay, how do you handle that when you change something? Or you like, do you have to resort the entire fucking thing? Not sure. I felt like I had it figured out before, but I guess not. Yeah, no, that would suck. But I think that's actually kind of how you do it. You store... The way I think you're supposed to do it is you store the entire voxel grid on the GPU as just like a boolean, true or false. And then if your ray strikes one of them, then you need to load it in. But that doesn't work that well with triangles. It works really well with voxels. Because then you know that it's gonna it's gonna hit, and then you can just load it in, and then you do like a round trip. You paint out which voxels you want loaded, and then you read that, and then you load all of those in an indexed array. And then you just read the data after that. But it works really poorly, I think, if you need to do it repeatedly for like you find a voxel and then you miss the triangle and then you have to find the next voxel. That doesn't really make sense. There's so many of these techniques that sound so smart on paper, but they only work for like very specific use cases. Oh my god. But at the end of the day, the vertex container, it needs to be stored in a way where the vertexes connect in the correct order. 0, 1, 2, 3, 4, 5, whatever. To render triangles. That's how this has to work here. But that might mean repeating the position information here. That also means that the position could be a byte. Huh? Why is it bitching here? Oh, it's over. It's too much. Oh, yeah. No, it can't be a byte. Can be a short, though. And then, like I said, we can have up to up to 8 vertices. That's 72. That sucks. That makes this really annoying and complicated. What's a bit field? Is this a bit I think I am bit fielding, right? Yeah. That's the unfortunate reality. But the memory usage shouldn't matter here. As it's, again, it's only the surface. And the surface is a minuscule amount of data compared to the entire thing. Still worth minimizing it, but... yeah. I don't really know what I'm doing right now or what I need to be doing right now, to be perfectly honest. Because we need to calculate this, but I'm trying to figure out like where should I store data, how should I store data, what kind of data do I need to store, what do we need to actually render this shit. And the reality is that every vertex or every voxel needs to contain every vertex that it needs in order to render itself. What was that? My phone ran out of power. And that does mean duplicated data, because we're gonna have a voxel with like an edge vertex and its neighbor shares the same vertex, but it's stored in that neighbor as well. But I think there's no alternative. There is one alternative, I guess, and that's storing the index for its neighbor that it's connected to instead. That's maybe doable. But I think it would be kind of the same. Because an index is actually kind of heavy. Because it would need to be able to point to any neighbor, really, right? So that would have to be probably an integer, because it would have to be able to be any one voxel that's stored in memory. I'll be right back. That's actually not necessarily true either. It would just have to be relative, right? So that means we could do it with like 6 bits. Because then we can have we can say which ones we're connected with. But I think that's bad. Maybe. Well, no, not necessarily. No, it's not that easy. It would need to be 6 bits per voxel. No, 6 bits per vertex in the voxel. So you'd have the vertex position for the source voxel, and then you would have a list of tries, or you would have a list of vertices for the triangles, and that would then be 6 bits that represent -1 and +1 for x, y, and z. So you have 2 bits. First, if the first one is flipped, that means -1. If the second one is flipped, that means +1. And that way we can point towards a neighbor even diagonally. And then we simply use the vertex value inside of its neighbor. But now we're loading. So now it's a question of, are we loading neighbors, or are we just storing it in the current voxel and just reading? But that would save data a lot, I think. But I don't think I really need to save data that much. So I think it should be kind of insignificant. Oh, holy shit. It's so fucked. And I still haven't even begun to figure out how to actually evaluate this shit. That's the biggest crux here. Because what we're doing here, this would be creating the surface net. Kind of. No, this is creating the contour. So here we're kind of calculating the sides. And that means we're creating the contour within the voxel itself. And now we need to test the voxel. Because that's where I feel like things differ for me. Is the kind of the other implementations I've looked at, like the John Lin one, he does this, right? He goes over the entire thing like this from bottom to top right, bottom left to top right, and he goes through these in order to create a surface here. But that's where he's creating the triangles. And that's where I feel like first we have to go through this. And we have to calculate where the vertex is. And then we can go over the vertices and then create the remaining vertices that we need to connect it all. That's how it should work, I think. So here now we have the corners and we have the sides. And now we need to test them in a certain order. We need to test the edges. And this is, we need to create should it be a dictionary? Dictionary key. And then it contains a tuple, which are two keys. Edges. Right, and then we have to create the edges in a certain order, and that's yeah. No, it's actually 12. And here now we have to say dictionary, no, edges. Well, hello, Kib. I think we can generate it here, like right away. It just needs to be like, how do you do this? It's like the key 0 and then the tuple, which is like 0, 4, for example, and then you just repeat that. For every edge, which is 12 edges. And now this has to be in like a certain order, like I said. I don't know what that order is. Actually, I don't know if the order really matters that much. Maybe, I don't know. We don't want to clear that. This is used to test. Oh, holy shit. Maybe I need to populate the corner array, because I think that's probably true. So there needs to be some logic there then. Hello, Nosy, how's it going? So to get the correct corners from the corner matrix, it's gonna be like that. Then we have 8 corners. Just thinking like when we're like voxel 0, 0, 0. That's that corner. This is then +1, 2. That's +1, +1. 3 is +1. And then here it's the same, except that is +1. Those are the corners. And this is where we need to do an edge test. And this is, it needs to be something like int c0 equals edges dot item 0 dot item 1, and int c1 is edges 0 dot item 2. And then we use that to access the corner array and get the value from there. That's a float. But what's the test? What am I testing against? Am I testing it against the volume of the current voxel? Oh, holy shit. Oh, holy shit. Ooh. Swallowed in the wrong windpipe. Ugh. Hello, Akon. How's it going? Jesus. Bro, I need to look up some examples here. This is fucking impossible. This is so hard. I don't know. Let us see. Breaking my head with Rust. Fair enough. Iterate at Good morning, Sleepy Charles. How's it going? So here's this solution here. Here he has already determined. Where do we calculate the edges? Sorry, I'm fucked in the throat. Oh my god. Here he's just determining the value. Fuck you. It's not this simple! I hate these implementations. He's just checking if if the value on the map is less than 0, then fucking do this bullshit. It's not that easy. And this uses a different method as well. Because here, I don't understand really. Because this is a density check, but here he's doing it like he's doing this already. This is like the next step, but he's doing the next step immediately. Which I find so strange. Because, like, where the hell have you... I feel like you haven't generated a vertex. Like, he's just getting a sample here. And that's it. Sampler.sample. Yeah, I don't know what that's doing. Where are you doing this? Sample. Image data. Image scale. Return image data. Yeah, I don't know. Like, this is bullshit. Total bullshit. Because what's the definition of less than 0? Like, what is that? Like, if this was a Perlin noise map, for example, then the value would be 0 to 1, so it would never be below 0. So it's just, that's just bullshit. But that's why I hate this example, because it's... I feel like it's just bullshit. Hate it. X-axis, Y-edges, axis, Z-axis. Is that the order we want to put the edges? Directions. Because what I'm doing is we have to add, I have to add another step here. Here he's just reading from the map, right? And he's reading the corners. Which is fine. We're not gonna read from the, because he's reading from the, like the vertex map. Or the vertex matrix. The neighbors. That's not what I'm trying to do. I'm trying to do it with the voxel itself. More or less. And such, I'm trying to read the voxel's corners. And as such, we're completely missing the key aspect here. Really, like, not even kidding. the most important part is completely skipped in this entire example, I think. Because here, he's just checking the map. And if the map is less than 0, then he's setting the corner. And that's it. So we have to calculate the isosurface here in some manner before we do this. And that's where we need the I don't know. Yeah, I don't know. Let's take a look at some of the tutorials I've already gone through like 100 times. Here we're doing octary bullshit. Child and min offsets. Calculate surface normal. . I think this is kind of what I should do. Maybe? I don't know. This doesn't feel like I'm calculating a surface. This feels like I'm calculating a gradient. Right? Because he's just taking like this point. If he's here, he's calculating the d of y by taking like this minus this, and x by taking this minus this. And then he has z as well. And then he just runs normalize on that. Like, I don't get it. Like, is that enough to get the normal? Because I feel like if you had this, you just get that. Wouldn't you? And then you have no idea like where up or down is. Understand. Yeah, like the surface rate of change for each axis. These values then determine the surface normal. Which is just completely skimmed over. Like he doesn't... Like what? Huh? Just normalizing that doesn't give you a normal. Just a normalized direction. And here, this is where some logic has to be added. Because here, he's checking the corners. And for each corner, here he gets the corner position from his array of positions. that he's calling child min offsets, which is to me nonsense, but he's doing that, and then he's fetching the density from the position of the child, and this is assuming that we have a high resolution source density that we're trying to read, which we don't. So this is where the corner values that I've calculated come in, right? And the density that we need to get here, because here it's going to say density is less than 0, then material solid, otherwise material air. So the density here is going to be the volume of the voxel minus the volume of the corner. That, again, I have calculated. And that is how we calculate whether the corner is inside of the object or not. Right? So for 0 corner.length, this is corner volume. And then we need full corner I'm just gonna call it corners, whatever. Hello, Green Branch. Going horribly. Horribly. This is really difficult. I don't understand what I'm doing at all. I have no clue. So we gotta say something like, if voxel matrix xyz dot volume contents, which is it? I think it's like minus. So here it's corner volumes I minus voxel matrix is less than 0, then we're gonna say corners I equals true. I don't necessarily hate coding. It's not that I like it either, though. But right now, I'm trying to create. I'm trying to implement a system called dual contouring, which is a way to create like a Minecraft world, but it's got smooth transitions between the voxels. I've been told Enshrouded does this, for example. It should be something like that. Let's take a look here. So here, if we are testing this voxel here, this voxel has a volume of 3, and we then want to compare it to this one over here to see if this side is within the surface. So then we take the target minus the source, so that's 1 minus 3, which means we get minus 2. And that does mean that this is within the surface. Or how is it? Like, here it's a little bit, I mean, I think that's true, because this is 3 is a surface. Like everything that has a value here is like within. And everything that's positive so here 7 minus 3, that's 4. Or is it the other way around? Man, I don't know. Anyway, the example there sucks ass. Let's try doing what I was doing before. That made a lot more sense. Let's just make a bunch of 8s here. 2, 3, 4, 8, 3, 4, 1. And as such, here, this should end up looking like something like this. Like there should be a surface here. And then that goes there, and then connects like that, and like there. So if I check here, we say 8 minus 1, that's 7. But negative is supposed to be within. So that means that it has to be the target minus the source. So then this is 1. Target minus the source. No, I mean... No, it's the other way around. Because this here, right? We're checking a side. So this is 1, this is 8. That means logically that this side looks like this, right? And that means that this side is within the volume. So that means that we have to take the source minus the target. And then we end up with minus 7 on this side. While over here, the source minus the target is 1 minus 0. There's this 0 here. Then it's positive. So let's take this again. It's source minus target. Source minus target. Then the corner is true. Otherwise the corner is false. That should be about it. And here we can say int corner count equals 0. And here we say corner count plus equals 1. And then here we're going to say if corner count equals 0 or corner count equals 7, then we return. And this is just false. There's just nothing there. It's just an internal voxel. Though I don't think it should return. It should actually say voxel matrix x, y, z dot volume, no, vertex equals null. Because that means it doesn't have a vertex, it's inside of the bounds. And yeah, that's just that. Oh. what we're doing here right now is we are trying to determine what the current voxel's vertex position is. And after we have determined the vertex position, we can then generate. But that it has to be like, this is stage 1. So I think this might not actually be part of this function. We have to do that first. We go through all of them and generate vertices for every surface voxel. And then we go through them again, and we then generate the actual triangles. But first, I'm going to the bathroom. I wonder. Yeah, maybe. Sure. I tightened the stiffness of the backrest, but I feel like if you have it like anything other than being like really light, you have to like fight it the whole time. You gotta get it just right. Okay. So Positions, edge count, P. I think I understand what this is for now. Yeah, it's a way to turn like Minecraft blocks into this, right? Just to simplify it. That's what I'm doing. A voxel is a Minecraft block. More or less. Or rather, pixel is a coordinate in 2D space, right? So your monitor consists of voxel or of pixels. You have 1920 times 1080 pixels on your screen, assuming you have a 1080p monitor. So then you can just pick which coordinate you want to look at, right? And a voxel is just the same in 3D. It's just a point in space that contains some information. And that information is usually just like an index, and an index is just a number, like 0, 1, 2, 3, 4, 5. 0 means it's empty, 1 means it contains whatever 1 is. And then you have a list of voxel types somewhere else where it says like 0 is air, 1 is dirt, 2 is grass, 4 is wood block or whatever. And then you just create the world by just placing those numbers out in the voxel grid. And then you, after that part, you've created the world and everything in it, and then you need some kind of way to render that, right? And there are many ways. You can turn it all into a mesh, which creates, that's the typical old school way of doing things. You turn it into a mesh, which is just a bunch of triangles stitched together in a very certain way, and then you just kind of draw them on the screen. And what I'm doing is called ray marching, and ray marching is, there are actually old games rendered in the same way. I think like Swiv or something like that. And also Wolfenstein 3D is rendered using ray marching techniques. And that's basically, if this is the world, right, with all these numbers, you got zeros all over the place here. Then the player is somewhere inside here. And the player is the camera. So if this is the camera, we then just shoot rays out everywhere. For each pixel on the screen, that we want to render, we shoot one ray. And then we see where that ray ends up in the world. If that ray collides with, say, this here, we then check, okay, which side of this did we collide with, and what type of voxel do we have inside here? Is this dirt or whatever? And then we check where on it did it collide, and using that position, we then grab like the texture, where on the texture should we sample this, and then we just draw that on the screen, right? That's basically what I'm doing. Now what I'm doing further than that is, typically speaking, voxels are just blocks, right? So you end up with a world that looks like this. Blocky terrain. That's Minecraft. This is a grass block. And here you have dirt. And this is what I'm trying to address. So what I've done is I've given each voxel a volume. So this one is grass, but it might be, if the volume is something between 1 and 8, then this might be just 1. And here we might have 2. And here's 4. Here's 3, 7, 7, 7, 3, right? But now I need a way to smooth this out. You can just say that, okay, if it's 1, then it's only this high. If it's 2, it's this high. If it's 4, it's this high. And then you can kind of get a smoother transition if you still want that like blocky voxel aesthetic. And that's what I don't want. So that's why I'm doing what I'm doing. So what I've been trying to do is I've been trying to like manually connect them together like this based on the heights and like really complicated logic. Just manually. And that's been really annoying. So now I've been recommended to look at these other methods. There's something called marching cubes. But that's really... It doesn't really seem like a good solution. And dual contouring, what that's doing now is we're gonna go through the entire world and we're then gonna create like corners, or we're gonna create points of volume around everywhere here. So we don't just have a volume here anymore. We now also have, like these are 0, right? So then we add all of these together, and then we put the average volume in the corner here. That's gonna be like 0.25 in this case. And then we're gonna do that all over the place, like over here. This is gonna end up being, if this is 8 in here, then this corner here is gonna be something, and up here, whatever. And then we have to check even the empty ones to see if there's something there in order to smooth this out, because this one here, this voxel here might be empty, but its corner down here actually has some volume in it. And then I'm complicating it now because I barely understand it. But basically, we're going to calculate how this is gonna end up looking, and it might end up being something like here, and then here there's a little corner. It goes over there, and then it goes up here. And then here, this might intersect up here, and then here we get a little corner in the empty space here. And then it's gonna calculate all of this for me. But it's also going to add some like in-between blocks when it smooths it out. Because otherwise, it's like a geometrical impossibility. Because that's something I ran into as well. When you have blocks that form corners, you can't in any way like smooth this out in a good way in 3D. Because the shapes are impossible here. Like some of these things here, you can't connect it properly, and even if you do, you then end up with like this area here is just always flat. This can't be shaped at all because this is the voxel below, and so you end up with this flat ledge everywhere where there's a corner. And the world becomes like hilly and weird. It's not very good. So I'm trying to do this now, but the logic is not so fucking simple, unfortunately. So I don't really know. We're like getting there, but it's And then there are other things involved, like I'm checking this right up here. He's showing me code and how he's done things. But first of all, this is C++, I think. And I'm using C#, which makes it complicated. And he's also using something called an octtree, which is like a way to store data. And that makes it even more complicated because the octtree is kind of convoluted, and all of this stuff is like for a different way of doing things than I'm doing things, so I have to like translate it, and it's super weird. And this now is where we need to get the edges. So we're getting the corners. Corner volumes? No, we don't want corner one. We want corners. No, we want this to be a certain corner. This should just be edges. So this is edges 0, or rather it's edges I, item 1 and item 2. And then I'm gonna use booleans here. He's using integers, but whatever. Okay. No, let's go with M0 equals corners D0. Well, M1 equals corners C1. Huh? Oh. And then if M0 equals M1, Then we continue. Otherwise, we want... I guess I don't understand this part. Because he's just checking the corners, and he's checking the density here, but the density isn't stored anywhere other than here, and this is a local, so it's temporary. And then he gets the density, then he sets the material, and that's it. And then down here, he's saying P1, P2, P1 equals leaf. I don't know how this works. I don't know what an arrow means in C++. I don't know what min is. But here he's getting child, he's setting min plus child min offsets. This is one of those bullshit things where, like, I think the min is the value within the node. It's like if you have if you're checking a leaf that's somewhere within, that leaf might have a min of like 7 and 6 in, or like 7, 6, 3 in XYZ. This is so strange. Yeah, I know. I'm reading that in Flutter you have child and parent widgets. I don't think that has anything to do with this. The fuck is Flutter? Something called Flutter. Okay. Well, an octree works like this. Or this is a 2D variant of it. If you imagine that we have like a coordinate system here, you've got 0, 1, 2, 3, 4, whatever. The purpose of the octree is it's something called a sparse volume. and it lets us separate space into larger sections that makes it easier to ignore. So if you have a volume here, this is an octree, this is the top of an octree. If this doesn't contain any voxel information, then the entire octree is set to 0, right? More or less. But if you put a voxel in here, then the octree is split. Actually, it's the wrong size. Then the octree is split into 4. And then this one says 0, 0, 0. But this one has a value because it has contents. So that means that now, if I want to check like this position down here, we just access the octree, and then we go as far down into the octree as we need to. Because it's like layers, right? The first layer is the big one with just the 1 value. And then we check that one, because that big value, that big one now has a value because there's something in here. So then we go down, and then it's split into 4, and then we can check down here and we see that, oh no, there's nothing here. But if I were to check here, then we'd have to go like even deeper in to check, because this here says like 1, and that means that, okay, we're checking this big section now. It says 1, that means there's something in here. Then we have to go in there, and then we have to check the actual position. And that might be empty. But it means that we can much faster skip these areas when we're checking something. And an octree doesn't need to have 8 children. It can have as many children as you want. It just really depends on the resolution you want. But typically, I would say, yeah. That's why it's called oct. And using this, right, you can split the world into sections like this, and it makes it a lot easier to do like calculations and check for collision and stuff, because you can just check if there's something there or not, and if there isn't, then you don't need to do any checks and you can just move the thing. Instead of having to check against every object in the entire world to see if they all collide. But I'm not using this system. I'm using a similar system called the brick map. And the difference is that in here, in the octree, we have all of this split, right? So we now have zeros here, and here we have value in this corner. But in the brick map system, it's as simple as this. Now it's 0 because it's empty. Now it's 1 because it's not empty. That's it. It's a lot simpler. There's a little bit more to it, but not much. But I'm confused. Approximate 0 crossing position. What does this mean? Finding the min along the edge. Const vec 3p. How do we find a min along the edge when we don't have a value? What is going on here? Oh, okay. Damn, that's clunky. But fair enough, I guess. I understand what he's doing here now. So basically, if we have a square, and we then have like value of 3 here, 7 here, and this is should we say five? Then we can do, what was it? Source minus target. Source minus target. 5 minus 3, that's 2. So that's positive. That means that this is outside. 5 minus 7, that's minus 2. So that means that this is positive. So this is inside. That means we know that the surface is somewhere here. But then we have to compare these. And we have to figure out where is the actual intersection, right? And I feel like I can have a much more accurate way of doing this than they're doing, because they are sampling like because I just have a bunch of voxels, right? And the voxels just have a value, a volume value, and then I'm trying to connect that. But the original way that these methods typically are like what they're designed for is if you have some kind of data like this, right? And you're now trying to find a threshold of how many, like the density of pixels in this area, and then you're trying to create a shape out of that. That's what this kind of method really is for. And because of that, they're like incrementing through it. Step by step by step by step by step by step by step until they find the correct threshold that they want to stop at to get like as accurate as an intersection as possible. But for me, my values are more like my volumes values are 1, 2, 3, 4, 5, 6, 7, 8. That's it. So if we have 3 and 7, I feel like all I need to do is just get like I don't know exactly what the calculation is here, but because if this corner is 7 and the center is 5 and this is 3, I feel like we want to get like a value in between here. based on the source. But I don't know what value. Oh yeah, fuck. Something like that. Some bullshit. And I don't know exactly what the correct way of doing this is. It could be something like 5 divided by 8, and then that's gonna give us like 0.65 or some bullshit. Yeah, I'm lost as well. I don't really know. But basically, this is the average volume up in this corner, and this is the average volume down here. And we have concluded that because this corner is negative, no, it's positive, when we subtract this value from here, that means that this is outside of the surface, right? And this is inside of the surface. So that means that there's this side is where the surface is intersecting. And then we need to figure out where is the surface intersecting. And that position is modified by how big the value is inside of the volume here, right? Because that means that if this value here is like 1, then it's going to go up here to try to intersect. While if it's 7, it's going to go down. So here the point of intersection would be, I'm not sure what it would be. Like if I should compare with the side here, maybe? Maybe the side here is 8. Then we would be able to say 5 plus 8 divided by 2 is 6.5. And then we can go like up here. Something. Or here would be the intersection. I think that might be it. But I'm not sure. Either way, I think we have to stop here because I have a laundry time in like 20 minutes. And we have been at it for 3.5 hours. I do think this is on track. But it's a winding track. I'm using like 7 different sources and like code examples to try to actually figure out how to implement this here. Trying to like extract parts that make sense, because so many of these guys are implementing like very specialized versions where it's like for an octree, or it's using a different kind of source, like a noise map or something, in order to create its vertices and And it's in C++ or it's in Python or... I don't even know what a quadratic equation is, I'll be honest. But yeah, I think this, for example, where he's incrementing this current t. Yeah. Well, he is actually just incrementing by 8 steps here. So this is actually pretty large steps. So this could work. But I don't know what the min value here would be. Yeah, what would happen here is if we translate this into this, what we would do is we would find this point of intersection by incrementing down here until the value here becomes 0. And that means that we need to find the point in between 3 and 7 where the value is 5. That's what needs to happen. And that should be this, I think. So we need to find where 5 is here. And it would probably be like down here, I think. Because when the density minus the source volume, or let's call this density. This is density, this is density. If the density here at the intersection, or the source minus the density here is 0, that means that that's the surface, right? So but yeah, I'm gonna go and deal with some laundry bullshit. Then I need to do some writing, and I'm gonna eat food, and it's Saturday, and whatever, blah blah blah. I might continue later tonight, we'll see. I might not. I really do want to continue, but there's a lot of stuff going on, so I might just chill. We'll see. Plus I'm doing laundry. But anyway. I think we're like halfway almost to figuring this out. Until next time, thanks for hanging. Have a good day. Bye-bye.